Right. My name is Dvir, and with me is Shai, and we're going to talk to you about doing some cool things with Redis and Spark ML, and the new feature of Redis is called Redis modules. So this thing doesn't shift the screen, the slides. All right. So, Redis, I'm going to assume a little show of hands. Who here has used Redis? All right. And who has used Redis beyond like a simple key value storing blobs of data? Hardly anyone. All right. So Redis, as you know, is an open source in-memory database, and I'll give you like an overview of it in a sec. Redis Labs, our employer, is basically a company providing hosted cloud and enterprise Redis, and we also employ Salvatore Sanfilippo, the author of Redis. I myself have been a Redis user for about 6 to 7 years and contributed a bit of code to Redis, and Shai has recently joined us at Redis Labs, and he's working on the Spark ML integration. So, just a recap of Redis. Started just over 7 years ago in 2009 by Salvatore Sanfilippo, just a very talented guy working out of his home in Sicily. And it's remained mostly a one-man show, and that's actually something that's important to our story here. It's probably the most popular key value store out there. Well, it's not, it's not me saying that. That's there's a lot of data on it, and a lot of companies use it. Just to name a few: Twitter, Netflix, whatever. Just name a company. I don't think Google is using it, but probably everyone else. So yeah, that's Redis. And if we're going to be a bit more technical, so Redis is not exactly a database or key value store. I like to think of it as a key to data structure store, which means your keys can be several things. It's in memory and everything is back to disk. Recently, like a year and a half ago, a cluster support has been added. And also you can use Lua to actually write macros and functions that run inside Redis. It's single-threaded, which is also important, but the trade-off is that it's extremely fast and it's flexible and pretty simple. So when we're talking about a data structure store, I like to think of it as a Lego for data. Okay, so data in Redis can be modeled as several data structures. You got strings, which you can also use as bitmaps or just binary blobs and bit fields. You got hash tables. Like Redis itself is just one big hash table, right? But your actual values can be hash tables themselves, or linked lists, or sets, or sorted sets, which are, to me, the most interesting data structure in Redis, which are sets where each element has its own score. And you can do range queries on that, and it's really interesting. You have geosets where each element has a location. Basically, by the way, it's just a sorted set where you take geo hash of the location and store it as a score, but it's abstracted. And hyperlog, which is a probabilistic data structure for cardinality estimation. So that's basically what Redis is. It's used for a lot of things. I personally, my favorite use case of it is what I call a front-end database. You may store your data in some other database, but when you want users hitting your database for production uses, and you want everything to be fast and predictable, and you want, when EBS is slow, you want things to still remain fast. Redis is great for that. It's also used for really a lot of things: real-time counters and message queues and geo and whatever. It's really flexible, and people are abusing it in a lot of ways. And in the past year or so, we've also started working on an open source integration of Redis and Spark. It's very basic. We have Redis RDDs that map your RDDs in Spark into Redis data structures or collections of keys, and it's pretty simple. And we've also added the Spark SQL integration, but basically it does two things. It's designed for two things. Either your data is already in Redis and you want to use that in your Spark job to join that on other stuff. Let's say you have, I don't know, user profiles and you wanna integrate them into an event stream coming in, or most probably what I suspect most people are doing with it is just you have a Spark job, it's doing something, and basically the output of some algorithm, the result of it is just saved to Redis. So Redis is flexible, but as a user, you often find yourself asking, well, but can it do that? Can you do full text search or secondary indexing or time series processing? And the answer is usually yes, but either you have to do some pretty complicated modeling on top of these 6 or 7 very basic data structures in Redis and some sophisticated tricks, or you can do that in the client application, which sometimes is nice, but sometimes has its limitations. Or if you really want to add some data structures, basically you can't. So let's say you want a new feature. I wanted a prefix tree a few years ago. I wanted an autocomplete server. So you have basically these 3 options or 4 options. So try to do a script. If you want a data structure, that's not going to work. If you want to bind to existing libraries, that's not going to work. And if you want to do computationally heavy stuff, that's also not going to work. You can convince Salvatore, Anti-Res, that this feature is needed. In 6 years, I've seen this happen maybe once with hyperloglog. So that's not likely, unless it's like a really trivial feature. You can fork Redis and just add the functionality yourself. I did that in the past as well. And good luck with that, because then if you have users, you're going to have to like backport your stuff, and it's going to get boring after a while, and not many people who started this path continued with it after like say a few months or years. Or you can build your own database, which is probably the hardest thing to do, but also the most likely to succeed. So that's been the situation until now. And this is all about to change with Redis modules. So this is a project that we started working on with Salvatore earlier this year. It's going to be in release candidate, I don't know, probably in a week or two, hopefully. And several modules already exist. We've been developing some modules at Redis Labs, and there are some people out there that have already started working on some very interesting modules, and I'll demonstrate a few in a second. And again, I think this really is a key paradigm shift for Redis, because again, up until now, getting new stuff into Redis was really hard, and I think for a good reason, because Redis is supposed to be compact and fast and simple, and just like adding every feature that someone needs is going to make it just the opposite, right? So I think it's really wise that in terms of new data structures and commands, Salvatore has been very careful about what's being added, and feature creep in Redis is really low for a 7-year-old project that's also keeping backwards compatibility with the commands when the protocol to the earliest version. But now everything is going to change, because the community can now add features on its own. And there's no need for forking Redis or doing any of that stuff. You just create your module and you extend Redis. So let's talk about modules in action. So what modules basically are just dynamic libraries that are written in C or C++, or hopefully soon JavaScript, because everyone likes JavaScript. And I'm actually working on a project to create a bridge for Go. That's sort of working. And the key thing is that we use a C API and ABI, a binary interface, that both isolates the Redis internals. So the purpose of that is that we can always break things from the inside without having you recompile or change your modules. And again, it's backwards and forwards compatible. So not only will your module compile 2 years from now, it will actually be loaded into Redis, and Redis will handle it because the ABI will also be stable 2 years from now. And once you write that library and you have near zero latency access to the data on Redis, you can extend it with new data types, you can extend it with new commands, and you can extend it with new capabilities. By capabilities, I mean not only adding a command that sums up 2 keys or whatever, but actually building a search engine inside Redis, whatever. So let's start with like a basic module example. Every modular system, like NPM, needs to have a LEFTPAD module. So I built a small left padding module. So we start by loading the module, and Redis has a command module load, and you give it the path of a SO file, and that's basically what it does. Although in production you don't want to do that, you want to specify in the configuration file the modules you want to load and not do it in runtime. And then if we do command info, which is like a basic Redis command that tells us a bit about what it has, we see that we have a command called example leftpad and a bunch of stuff about it that I'm not going to show because it's boring and takes a lot of space. And now we can use leftpad. It's just a basic command that does left padding for a string, and we leftpad foo by 8, and this is what happens. And we can also ask Redis to pad it with a specific character, and this is what happens. So that's like the most stupid module I can think about, and just to show you the mechanism. A few, let's say, more mature examples. One is RediSearch, an implementation from scratch of a search engine, an inverted index. It uses actually Redis strings under the hood, but it encodes binary encoded compressed inverted indexes on top of them. And it also has the stemming and all sorts of things you'd expect from a search engine. It has a fuzzy autocomplete, which is implemented with a custom data type. There's a try with a Levenstein automaton. And I've benchmarked it to be like up to 5 times faster on the same data set and queries than Elastic and a search installer. So that's like a really small example of the API. I'm not going to show you how to index, but basically you search and you get results for your query, and you can also get suggestions that can be fuzzy from a dictionary that you're building. If you're interested in that, it's over on GitHub. It's open source AGPL, and you can just go and use it. Another one is secondary indexing. Redis basically doesn't have secondary indexes. You can model them yourself, but here we've implemented a module that actually tracks objects in Redis, treats them like tables, even though they're not, and it's schemaless. And it can actually track objects, and you just proxy the commands. Here you see I create an index on user's name and age. The type is hash, and the schema is name is a string and age is int32. And then I'm into user's name and age. I run a Redis command hmset, which basically sets fields in a hash table. And I'm saying user1, his name is Alice and age is 30. And now I can actually query Redis and give it like a where clause, and then I proxy a read command of Redis using a $sign instead of each ID, and it just it's equivalent of basically getting the IDs and running the command. So that's extremely nice and powerful. Another one is JSON store. So right now, if you store a JSON blob in Redis, and a lot of people do that, you want to change some little thing inside it. Basically, you just you have to read it, modify it, and save it back. And with this API, we can actually modify or read just a specific path inside the object. So now I'm going to hand over the talk to Shai, who's going to dive deeper into what we did with modules and Redis and machine learning and all that stuff. So thank you for now.
Well, good afternoon, everyone. So as Dvir said, I'm going to talk a little bit more specific about a new and exciting research model that we've been doing lately. And this is the Redis machine learning module. So Redis and Spark, until today, it has been the connector works pretty much the traditional way, so you can use Redis as a data store or use it with the Spark connector as a very fast RDD. So for machine learning, you could, for example, if you run a batch of recommendation engine algorithm, you can just put the results in Redis. But as you've seen with the possibilities of modules, we felt that we can do much more exciting and interesting things. So we looked at the world of machine learning, and the first thing that we noticed was that all the platforms, they're dealing with creating the model. But after you have your machine learning model, how do you put it in production? Where do you store it? And how do you query it? And we didn't see no standards. If you work with the cloud-based solution, you're locked to one solution. A lot of companies are developing in-house solution, which is always a pain. So we thought it would be a good idea to have some kind of a machine learning model database which can actually hold active models that can do the regression and classification for you. And this is actually perfect use case for modules, because with modules we can define new data structures that are required for the machine learning models. And the data that we store, we can use it to actually perform the calculations of the classification and the regression directly on the server. Another very advantageous point, especially for me, the modules are written in C, so it guarantees that if you want and if you work hard, you will get the best performance available. And you can also use existing open source C and C++ libraries like libsvm or libatlas or that kind. So if you do all that, you get a system where you do the training on Spark, and when you finish the training, you just store the model on Redis, and then you get a system which, like any other Redis server, you get high availability, you get clustering, persistence, very high performance, and client libraries in almost all the languages that we know of. This is a flow of how usually things work right now. So you do the data loading and the training phase on Spark. Then you can either save your model to a Parquet file or do a batch evaluation on Spark. And then usually a custom application that you write loads the Parquet file and serves it to the client application. If you use the configuration with the Redis-ML module, you just save the model to Redis, and it's ready to serve and perform in a production environment. The machine learning model is a pretty new module. So right now we just support these data types. It's tree ensembles, linear regression, logistic regression, and matrix operations, some linear algebra. And we plan in a short time to complete the whole spectrum of available machine learning models. So as an example, I'm going to show the forest data type. It is suitable both for random forest and other tree ensemble algorithms like gradient boosted trees. So it's a pretty simple data type. It's a collection of decision trees. Each decision tree has nodes that can be either categorical, which has to be equal like a string value, or numerical, which is splits into a range. And the trees can perform classification and regression. The classification is done, it's exactly like the Spark module. Anyone here used random forest on Spark? Oh, pretty good. Okay. So the classification is done by majority voting of the trees in the forest, and the regression is just the average value. This is an example of a simple decision tree. It's for the famous Titanic data set, where each passenger has 3 parameters, the sex, the age, and the number of siblings and spouses on board the Titanic. If we check this couple, so the girl immediately gets to survive, and this poor guy, he's male, and his age is larger than 9.5, so he dies. This is how the actual API look, how you type the command in the Redis client. So to add a node to a forest, it's a forest add. The forest ID, the tree ID, the path, which is a sequence of lefts and rights to the location of the node in the tree. Then a splitter type, whether it's a numeric or a categoric, the splitter attribute, and the value. If it's a leaf node, you just have to put a predicted value. And to run classification or regression, you just use the command forest run with a forest ID and a feature vector. This is an example from the Redis client, how it's done. You load the module. Then you create a forest. The ID of the forest is my forest. The ID of the tree is 0. The path of the root is just a dot. And it's a categoric node where the sex equals male. Then on the left leaf, you return the value 1. And on the right leaf, the tree should return the value 0. So if we run it, if the sex is male, you get 1. And if the sex is yes, please, you get this. Just some lines of code from the Spark shell. This is how you use it in the Spark. So we wrote a small Spark package that you don't have to actually write the command. You just create a forest object with Spark, and you load it immediately to Redis. So you import first the required libraries, then you create the random forest model as you would usually do with Spark. Once you have this model, you create a new object. This is the value f is the new forest model, and then you just load to Redis, and it's ready to serve. If you want to perform some classification, just send the command to the Redis server. A little numbers regarding performance. So I used the data that is supplied with Spark in the examples of the MLlib, and created a forest of 15,000 trees. To prepare and save this kind of a model from Spark to Parquet takes about 3.5 seconds. If you do it with a Spark Redis-ML, it's about 300 milliseconds. Load the model back to Spark takes about 2.5 seconds. And with Redis-ML, you don't need to do that, so it's 0 second. And the classification time for each feature vector in a standalone Spark, it takes 13 milliseconds, and with Redis-ML, it's 1 millisecond. So you can see the obvious improvement in performance.